how do you debug a code that is deeply nested inside a dependency injection container? Let's take a simple web application as an example. Here we have an entry point in the form of a minimal endpoint that calls a handler, and that handler in turn calls an AdBlue service client. The AdBlue service client itself relies on the HTTP client, which is properly configured in program CS inside of the DI container. Now here's the question: what if I wanted to verify only the specific method, whether it works correctly or not during development? Up until now, I had to spin up the entire API, prepare the right payload and authentication for the endpoint that triggers the service along the way, and then send the request using a tool like Postman. That is a lot of hassle just to debug a specific piece of code rather than the entire end-to-end flow. However, there is a better way to do this now. You can use the C# DevTool extension in VS Code and AnyFork, which allows you to create a runner. Thanks to this, you can either run a specific piece of code or debug it in the exact same way you would debug or run during a normal application startup that utilizes a dependency injection container. Right now in VS Code, I have this create runner codeless, which on click will show me this simple interface, allowing me to create a new runner. So I'll just give the sample runner as the input for the name, and then I'll just click create runner button. And after a while, I will get this new file called sample runner CS with this small piece of code in which we have the sample runner class, and automatically we have this AdBlue service client injected into the constructor. And in our runner method, we can now specify what sort of parameters we would like to pass into the call-async method. And in this file, we can use all of the benefits provided by C# LSP. So maybe let's create a new GUID for the order ID, and I'll just create a new cancellation token as none. Maybe let's just add some console write line. Let's say result order ID. So typically, to debug any piece of code, you have to set a breakpoint. And now to run this runner, we can either choose the run option or the debug. But since we want to just debug it, I will click on the debug option. And after a while, this application will be built. And we'll see in a moment that the runner is available for the debugging inside VS Code. Right, so now I can just navigate inside the call-async method. And here I can see exactly what is the response from the service that is deeply nested in the DI container. What is even more interesting is that if we take a look at this HTTP client, here during the configuration in the startup program, we are going to define the X API key with some value that is provided from the application settings JSON file. So let's take a look at this app settings JSON file. And indeed, in the development JSON file, we have this AdBlue session with the API key, def API key. But what if I would like to use the production value directly from the app settings production JSON file? Well, to do it, we can go back to our runner, and you can either click on the configure option, or here in the tools section, we can also go to the runner setup configuration option. And one of the parameters that we can set for a runner is the environment. And by default, this is just set to development, but we can also change it to production. And in this way, the runner will now automatically load the app settings.production.json file. We have some other options here as well, one of which is the auto register concrete types. And this basically means whenever this is set to true, in such cases, we don't have to rely on the interfaces, but instead we can just inject concrete types directly into our runners, even though if we take a look at the configuration for this client, it's directly registered as AdBlue service client. Going back to our runner setup, last option is the configure services method, in which we can pretty much override, add new, or replace the existing services that are defined in the program.cs file, if that would be the case. Now, since we have changed the environment to production, let's go back to the sample runner. And this time if I click debug, and we will go back again to the output service client. And if you will take a look at the HTTP client, well, as you can tell, now the X API key has the value from the production app settings JSON file. So this is how we can actually configure the environments in our runners without any additional hassle. And again, you can use it to debug or run specific methods. And as I mentioned previously, the runner class is part of the C# LSP, so you can benefit from all of the LSP features like hovers, go to definitions, or even quick fixes in the C# file. So now you might wonder whether the specific files for this sample runner are part of the Git repository. Well, if I would go to the source control tab, as you can see, nothing is added to our solution. So even though there's a project created for these runner methods, it is not going to be a part of our solution, but still we can benefit from the C# LSP inside Visual Studio Code or any other fork. If you would like to try it, you can just install the C# DevTools extension for Visual Studio Code or any other fork, and then create a new runner, as I did, or just by clicking the plus option in the Tools section under Runners.